Hello everyone! It's the 5th of October, which means it's time for the 5th Leetcode challenge question. I'm Victor and I'm solving each one of these in a raw unedited format so you can follow my thought process, or more likely that I can follow my own thought process in a few years' time. And disclosure for this one, for my future self or for you, this question I actually got to read it already and attempt an implementation when I noticed that my recording is not recording. So I actually am familiar with this question. So yeah, without further ado, let's go into complement of base 10 integer. So the question is complement of base 10 integer. Every non-negative integer n has a binary representation. For example, 5 can be represented as 101 in binary, 11 as 1011. I'm recording now, right? Yes, I'm recording. Let's create this. So what that means, if you're not familiar, I'll go through a very brief explanation of binary. So if we have the number, binary number, 101, how do we know that this is a 5? Well, each of these digits, 101, with most significant is the left one, least significant is the right one. I guess it's not really well represented. I'll use this one as an example. Which one was the 11? This one is the 11. Okay, let's do the 11. What I basically do is multiply them, the 1 and the 0, by the power of 2 that they represent. So for example, the least significant is the power of 2 to the power of 0. The one next to it is 2 to the power of 1, the one next to it is 2 to the power of 2, and the one next to it is 2 to the power of 3. So those are the powers, so this is powers of 2. And what do they mean for regular decimal numbers? Well, 2 to the power of 0 is a 1, 2 to the power of 1 is just a 2. Oops, let's do it like that. 2 to the power of 2 is a 4, and 2 to the power of 3 is an 8. And what does this mean? Basically, I'm multiplying the ones with their decimals here and the 0, so they're always a 0 regardless of what power of 2 they're representing. So this would be an 8, this would be a 0, this would be a 2, this would be a 1. And now all I have to do is sum those together. So 8 plus 0 plus 2 plus 1, which would result in 11 in decimal. And that's how we can represent that. That's why 1011 is represented as an 11 in decimal. And of course, the maximum number that I can store using 4 bits, so 4 of these pieces of information, would be 1111, which would be, instead of a 0 here, a 4. This is the maximum possible number, which would be 12, 14, 15. So this means that in four distinct bits, I can store at most 16 different pieces of information. So basically from 0 to 15. That's why they sum up to 16 in total. And the values themselves are 0 to 15. So yeah, that's enough explanation for binary. Let's go with the question. So note that except for n equals to 0, there are no leading zeros in any binary representation. So this is a very important piece of information, since integers in Java are represented as 32 bits and they're actually signed, which means that they have their leftmost, so the most significant bit that's supposed to be, like, let's say if I have this is 4, 8, 16, 24, 32, right? 1, 2, 3, 4 times 8. So this means that I would have a leading 1 or a 0 depending on the sign, whether it's supposed to be a negative or a positive number. And what this means is that I cannot use any like regular raw binary manipulations, I think. Well, I can use them, some of them probably. Can I? As long as I don't care about, I mean, I know for a fact that all of them are positive. Oh, anyway, I'm not gonna think too much about it. This is like binary stuff I don't do at all on daily basis, and I definitely don't do in Java. I've done some binary stuff in C for my Arduino project, so I'm not really much of an expert. We can check out the optimal solutions afterwards with the regular binary stuffs. But let's go with the question. So yeah, need to remember that complements are only on the leftmost significant bit that we care about, which is a 1. So for a given number n in base 10, return the complement of its binary representation as a base 10 integer. So 101, which is the 5, returns a 2 because it's 0, 1, 0, the inversion. 7, which is 111, returns 0 because 1's flipped are only zeros. And 10, which is 1010, would return 0101, which is the 5. So we're taking as an input base 10 integer, we're returning as an output a base 10 integer, but intermediary we need to do some binary stuffs. And the most possible, the max possible number is actually in the, I think 9 zeros is a billion, right? Integers in Java, signed integers even, and Kotlin hold a bit more than 2 billion. So we should be fine with just regular integer types. So let's take the function and do a solution. So the easiest solution I can think of would be something in the lines of n dot to binary, no, string. Yeah, to string using radix of 2. So radix means it's basically the return something, whatever. So let's just see if it works as I expected to. Bitwise complement for 5. So this should return 101. Yeah, so radix is the counting system that we're using. So if I just say radix 10, this is the regular one, so 5 should just be the 5. But if I say 16, this is the 16, this is base 16. So in base 16, the decimal 55 would be represented as 37. And something smaller like 40, like 17, no, let's say 15, would be represented as an F. Because it goes from 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, A, B, C, D, E, F. So that's why it's called base 16. It's pretty convenient when working with low level stuff, but I don't really care about it, just want to show it. So, and yeah, this 15 is going to be represented as 1111. So I can take this, I can have this string. I have this string as a binary string. Then I can inverse the bits in this string. So basically, I have to replace all ones with zeros and all zeros with ones. Strings are immutable though, so I will need to use it, some sort of a container for that. So first val binary string is this. Oh, I can just use a char array. Okay, that's nice. So I can just say to char array here. So I have a char array, and char arrays are actually mutable. So I can just go for each. So binary string for each indexed. So here I can take the index and char. What don't you like? Do they need to be in? No. Damn it, I always forget how to do this since it's different in Kotlin and in Java, the lambdas. For each indexed, it takes an action, so it takes like a lambda. Oh, I just need to do it with this, use this. So it's index and char. Yeah, in Java I'll need the regular brackets. Okay, so index and char. I'm gonna say if c equals 0, then binary string of index equals to 1, else binary string of index equals to 0. So that's how I'm going to invert them. And now that I have the inverted binary string, I can just say return this binary string. Oh, it's not a binary string anymore, it's a binary chars dot to string dot to int, and then I can pass the radix 2 again. Right? This is how radix is used here. Parses the string as a number, exception. Why don't they have the documentation of the radix? The radix is used while parsing, yes. The integer represent, whatever, we can just test it. Right? So I can say the reverse of 15 should have been 0. Let's just see what's gonna return like that. Nothing. Number input for string something. Why don't you print the binary chars for me, please? 0, 0, 0. So this is exactly what I expect. And binary chars to string should also be 0, 0, 0. Oh, it's the to string is wrong. Do I need to say join to string with nothing? No, this adds some separator, nothing. Okay, so now it's a regular string. So this is what I wanted to begin with. Can I just pass this without saying separator? Yeah, it's by default separator. So I need the chars to be joined to string. So what are they gonna return now? And of course, print whatever you're returning, 0. And if it's, let's take some of their examples. So we need the 5. 5 should return a 2. But it returns 1 and 0. And 10 should return 5. Okay, so if you add radix 2 here, it returns the 5. And the 10 should, wait, this was the 10, right? The 5 should return 2. Okay, so this works. I think it's gonna work here. Oh, wait, we also need the case where a 0 should return a 1. Does it work? Because it's an edge case of some sorts, but basically the 0 is a single digit, so we're gonna pass through this and it's gonna work anyway. So let's try this solution here. Okay, let's see if we can pass the tests. Okay, so we passed the tests. Now, I'm sure there are like much better ways to solve this without using strings. Let's try to think of a way to do this without using strings. Basically, I'm thinking in the lines of this, that note that except for n equals 0, there are no leading zeros in any binary representation. What does it mean? It means that my most significant bit, as I had in the example, I deleted my example. Anyway, if I have this example for the 10, which is 0, 1, 0, which we already discussed, that would be 8 plus 0 plus what is that? So 1, 2, 4, 8. Yeah, 8 plus 0 plus 2 plus 0. So this is why it's 10. The maximum possible number would be 8 plus 4 plus 2 plus 1, which is 15. But what's really cool about this is that the way we can find the maximum number without having to do any binary, well, we kind of have to do some binary, right? But 15 is basically 16 minus 1. And why is this important is that if I represent the binary as 4 symbols, it doesn't matter like what those 4 symbols are. I can take, if I add one more, I would need to represent them as 1 0 0 0 0. So if I have 4 symbols, then they can be this number minus 1. Why? Oh, because 1 0 0 0 would be basically the maximum, or one more than the maximum possible number, which in this case is 16, because it would add one more bit here, which would be 16 plus whatever, which is here 0. So it would be 16 plus whatever, but if I count this always as a 0, then it will always be like one more than the maximum possible that I could achieve if I had only 1 1 1 1 here. So if I have this number, if I have this count somehow, then I can just say, give me this number, which has one more character, that's a 1, and the rest is zeros. Take this number, deduct 1 by it, and this is the maximum possible representation that I can have for the integer that I have as an input. So if I have the input 10 and I know that the maximum is 15, then I can just say 15 minus 10, and 15 minus 10 is gonna be like the what is this called? The complement. Basically, it's the complement. So how can I count this in an easy way? So I already have this solution. I'm just gonna move it to a method. So string solution. So can we do another solution? So how do I know what is the closest power of 2 to the number I have? I guess I can go in reverse. Like I always keep mentioning how I can do binary from how I can do the binary to integer. How do we do the reverse though? So let's say we have the integer 5. How do we turn it into something else? We can do like modulus, so 5 modulus 2. This is again not optimal. There is definitely a better way to do this, I'm absolutely sure, but I don't do binary stuff often, so I guess I'll have to do with that. So 5 modulus 2 is a 1. Why? Because dividing 5 by 2 has the leftover of 1. And then I can say divide 5 by 2. Which would return 2. Again, I do this one more time. So I have 2 modulus 2, which would return a 0. And then I can say 2 divided by 2, which would return a 1, because 2 divided by 2 is 1. And then I can do it one last time, which would be 1 modulus 2, which would return a 1, because you cannot cleanly divide 1 by 2. And then I say 1 divided by 2, which would result in a 0. So basically I can say this is my number, 1 0 1, and I do this until I have the remainder, until I have my base number as 0. So let's try to do this like without actually being a solution. Let's just see how it looks like. If I say var num equals to n, while num bigger than 0, just do a print num modulus 2, but just print it, not print ln, and then num divided equals to 2. Return whatever, and see what will happen if we call this. Oh, I need to call it with something like I wanted the 5. Oh, I think I prefer 10 as an example. Or even, I want something asymmetric actually as an example. So what is asymmetric? I guess 11 is asymmetric. Is this correct? Is this 11? I think this is reversed 11 though, right? Because 1 plus 4 is 5. 5 plus 8 is not 11. 5 plus 8 is 13. So I basically wanted it mirrored. I want 1 1. I want 1 0 1 1, which will be 8 plus 3. But right now it's mirrored. Well, actually, I don't care about that. You know what? I don't care about that. I only care about the number of steps it took. So I want to know that there are 4 characters here. So as long as I know that, I'm happy. I don't care if it's inversed or not. So I don't really care about printing this. I just care about counting the number of iterations. So var count is 0 and then count plus plus. So I care about the number of iterations. And as long as I know the number of iterations, this is my maximum possible integer, right? Plus 1 minus count plus 1, the power of 2 of this minus 1. I'm gonna write it, see if it works, and then I'm gonna explain it, okay? So I think it's pretty cool. It's again not optimal solution, but it's pretty cool. So I'm gonna say math.pow. Oh, it only takes doubles. Can I do power for integers? Why can't I do power for integers? This is a bit dumb. I guess I can just always use 2 in the end. So I'm just gonna say 2 to the power of count plus 1. I guess this needs to be... Can I just say count to double plus 1? I should be able to. This also needs to be able to double. And this entire thing, whatever I get out of it, I'll say minus 1. So this is my var max. Val max. I don't need to change it. So this is the max. And basically, I'm gonna return max minus n. And this should be a working solution. Oh, max to int minus n. And this should be a working solution, I think. So again, let's try it with a 5. 5 should return a 2. It returned a 10. Okay. And 10 should have returned a 5. It returned 21. Huh. Did I do something wrong here? Do I not need this minus 1? Or this plus 1? 2 to the power. Huh. I want to see actually what is the count here. Count is 4. So I'm basically saying 2 to the power of 4, right? 0, 1, 2. Oh, that's why. Yeah. I don't need this one. I'm forgetting the 0. So basically, this is 2 to the power of 4, which is 16. Minus 1 is 15. So this is 2 to the power of 0. That's what I forgot. So 2 to the power of 0, 1, 2, 3, 4. And since I took 4 rotations to get this down to 0, this means that I have I represent this integer as 4 binaries, binary 0 or 1, bits basically. So this means that the number of iterations is already 1 more than the number of bits that I'm using, since the first bit is actually the 0th iteration. So this way I have the correct power, and then I deduct 1, which would be the maximum possible I can do without using this one. So basically I'm doing 1 0 0 0 0 minus 1 is 1 1 1 1, which is the maximum possible, and if I deduct the original input, then I get the complement. I think it's a pretty neat solution. I just need to make sure, does it work for a 0 input? Let's see what happens on a 0 input. 0 input? 0 input returns a 0. Yeah, so this is the edge case. This is why they had this here, this n equals to 0. Because in this case, it's a very special case, since I take 0 iterations. Basically, if number is, I'm saying here, if number is bigger than 0. And I basically just skip this altogether, and I return the 0 itself. So I can, this is really easily fixable though, because it's the only edge condition. I can have a simple if n equals to 0, well, return 1, and I cover it like that. What is the IntelliJ suggestion here? To use 2 to double.pow. Okay. Oh, let's take this and see if it works as well. Oh, it seems to be working. Did I do this? I think I had this before. Without this, it doesn't work, right? Yeah, it doesn't know what pow is. So this needs to be added there. Okay, submit. All right, amazing. Okay, so I guess that's it for my implementations. Let's go and see how the others did it. 100% easiest Java solution. N equals to 1, while n less than 1, and this is OR, so this is the binary OR equals, and then n shifted by 1. So when n is 5, which is 0 1 0 1, n is 7. Oh, and then he XORs it in the end. I mean, there are definitely some neat tricks there that you can do. Definitely doing Boolean algebra is better than what I'm doing. But yeah, since I don't do these things in... since I don't do this very often, then I could not come up with this solution without looking up how to do the binary operations. I think this is similar to my solution though, right? Oh, this is using math.log. C++ simple one-liner. Damn, I would definitely not like to see this in any production code. Runtime is of 1, spaces of 1. I guess it's like pretty good. I mean, he has this if check that I also have here. And then he has n to the power of 1 shifted by 32 minus, what the fuck is built-in COS? I mean, he's doing the same thing that I'm doing, but he's doing it as a single binary operation. I definitely don't know how to do that, but it's pretty neat. Wait. Looking at these solutions, can't I say like, give me the most significant bit? There was something like that. Let's just go and do this, extract this to double solution. Can I do something like return 0? I don't care about return 0. Can I do something like n dot most signi what bit? Take highest 1 bit. Oh, What do you want? Oh, it's experimental in Kotlin. I forgot about that. I can do just the Java one. Integer dot most. What bit? Highest one bit. Okay, n. And just print it. I want to see what it is. Wait, this is 0. So I can do the 5. So for 5, the highest one bit. For 5, the highest one bit is 4. Is this true? So I have 101, which is 3 numbers, and then the 4th one is there. If I say 8, it's, wait, why is it 8? Huh. What does this return even? Returns an int value with at most a single 1 bit in the position of the highest order, leftmost 1 bit in the specified int value. If 0, if the specifier has no 1 bits in the 2's complement binary representation, that is, if it is equal to 0. If I pass 7, return 5, pass 6, pass 5, okay, so if I pass all the way up to 15, it should still return an 8, right? And if I pass 16, it will return 16. Can I use this somehow? I'm a little bit confused. I mean, why would I need 8 bits? If I have, let's go back to the smaller ones. So if, let's say I have a 5, which returned an 8 before, right? No, it returned 4. So my 5 is 101. Oh, it returns the value of the leftmost. Okay, now I got it. So the biggest number I can represent with my leftmost significant bit here, 1, is 4. Since this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, which is 4. And if I pass a 7, that's still the case. And if I pass an 8, well, this is no longer the case, since 8 is 1 and zeros here. And if I pass a 15, it will still be an 8 because I have 1, 1, 1. This is the leftmost significant bit. So this is my this is what it will do. So can I take this and shift it one bit to the left? So let's say I have this, which returns an int, and I shift it by 1. Oh, Kotlin shift bit. Shift SHL, shift to the left. So it's just SHL. So SHL. This should be 16. This is what I want it to be 16. And if I have 7, I want it to be 8. Okay, so basically I can do the same solution like that. I can take this and say -n. So val max is this, and then return max -n. And this should be a solution as well, if I print it. I know for 10 that it should be the 5, and for 5 it should be 2. It's not being 2. What's wrong with it? I'm somewhere forgetting to deduct 1. So I need this. So I basically did the same thing a little bit earlier, but I did it without using the bits, which is obviously slower. So this should be also a good solution. So I don't need this shit. I basically manually did this before. Run code. And this should be just valid. It should be absolutely in the same way that I just had last time. It should be valid as well. And today I learned something new. I never knew of SHL, that this is shift left, so there's probably SHR. And there is shift 0 to the leftmost position. Whatever, I mean, those things are pretty nice in Kotlin. I like them. Those infix functions. But you need to know they exist. But I mean, I'm not sure if this is nicer than this. I mean, this might be. If you're used to it, it's nicer. SHL is like the same. But at least it's a function, so I can just control click and see what it does. Oh, not really. I know that it exists. I cannot really see what it does because it's just an interface. But yeah, so this was all for the binary complement in Leetcode. Thank you everyone for watching. Day 5. Hopefully I can be successful in tomorrow's challenge as well, and I can keep doing it. This is a challenge to myself as well. I'm not very good at being consistent, so we'll see whether I complete this entire project or I abandon it halfway through. Well, in any case, thanks everyone for watching. Probably the only person watching would be Victor in 1 year, but if it helps anybody else than me, then I'm very happy that I'm doing it. If it doesn't help anybody, then I'm still happy that I'm doing it for reference purposes. So having said that, bye bye and see you tomorrow.